Hi guys, here we have another application of integration, solid of revolution. So let's have a function y equals to fx for a to b, x lies between a to b, and you see the shaded area of the curve y equals to f of x. If this shaded area is revolved about x-axis through 360 degrees, a three-dimensional solid will be formed. Okay, so this kind of solid will be formed if you revolve from A to B, this about x-axis. This is called solid of revolution. So let's talk about in detail. Let's take a function f of x. It's similar to the previous one, y equals to f of x between two values of x, as we assumed A to B something. Now if you revolve this line around x-axis, you'll see the revolution is happening here. Our curve is rotating about x-axis, and another kind of solid is formed, which is called a three-dimensional shape, and the shape depends on the curve. Okay, so this cross section, you understand cross section. This is the cross section area, so which will change as you change the values of x. See, a small solid, a small circle, and a big circle at the end. So basically it's an area of circle. So just we can find the area by integration. Similarly, we can also find the volume by integrating. So we should know how to find such a volume. We need to understand this. Let's take a simple one, a straight line, y equals to x from 0 to 5 maybe. Now if you rotate this line around x-axis, you see, can you guess the shape? Yes, exactly, it's a cone. The solid cone is formed. We have created a cone. Okay, now the volume of the cone is what? So as you know, area of base into height. So we see from 0 to 5 is the height, and the area of the base is the circle here. So 1 by 3 pi r square into h. So height is h, and this is the circle area pi r square. This becomes radius. Okay, so remember, we will take this advantage from this point to that point. This becomes a radius. So the volume is 1 by 3 pi 5 square into 5, because the height is also 5 and the radius is also 5, and we got the volume. Now let's generalize this idea to figure out the formula or the procedure how to figure out using integration. So let's take another function at the same one, y equals to f of x, and if you revolve it, let's see what is the solid formed. Yeah, the solid is there. Imagine this solid cut into thin slices parallel to its height. Okay, see, now each slice is representing something. For example, if you look at this, it's like a coin, so coins are stacked to form a solid, and the normal shape of the coin is actually a cylinder, and the volume of cylinder is area of the base times height. So you can see here how it's changing. So if you generalize by taking x and y a point on the curve, so you will see the area of the circle, and this is the height actually of this cylinder. So we'll take it delta x or del x, whatever you call it. So that is delta x, and delta v will be the volume, means the small part of the whole volume. Okay, so can be calculated just using this disk. So delta v would be pi times y square by y, because y is the radius from this point to this point. This is actually y. Okay, times delta x, the thickness. So the volume becomes pi times y square times delta x. Now we will also convert into integration. Just wait. Now if you want to calculate the full volume, you need to add all these disks. I mean the volume of all these disks. So let's take summation of pi y square into delta x. That will be the approximate volume. So of course the accuracy depends on the thickness. If your thickness is minimum, more is the accuracy. So that's why we are approaching to 0. We are using limit here. And here we can say integration of pi times y square dx. So that's actually the key point for volume. Pi is always there because it's a solid, and y pi because it's the area of circle. Any line or any curve you rotate, it will form a circle at the base, at the cross section, and the height depends on the values of x. What you take from here till this point, okay? This becomes height. So del x is the representing the thickness, pi into y square. Y is basically the function, okay? So remember, you need to square the function times by pi and del x. Integrate from the limits. That's called volume of revolution, okay? So that's called the formula as well. So here is an example. Again, I'll show you the formula. So the volume formed when the curve y equals to fx is rotated about x-axis is given by pi times y squared dx. Remember to put the limits. So let's take an example. So we have an example of reciprocal function 1 over x from 1 to 4, and you can rotate by x-axis, also by with x and y-axis, but here I'm talking about x-axis only. I'll hide this. Yeah, here's the function y equals to 1 over x. This is 1, this is 4. As you grow from 1 to 4, the area of the circle will decrease. So if you rotate it, this is the solid formed. It's like a cone, but not really cone. So from 1 to 4, pi times y squared dx. Now you remember, in area we don't take square, okay? Because in area there are 2 parameters, length into width, but here are 3. Area times thickness, okay? So remember this thing. So y equals to 1 over x. So substitute here. You can take pi outside because pi is a constant number. So 1 over x squared dx. And remember to take the limits from 1 to 4. So this is the volume of solid of revolution because of this function from 1 to 4. So you can simplify this. X raised to power minus 2, the basic rule of integration, and you figure out the value becomes pi times 3 by 4 cubic units. So here are some, you can pause this video to solve these questions, okay?